Okay, so we're going to be graphing a piecewise function. So you're supposed to follow your 3 steps, right? So your first step is to find your breaks, right? And you're going to draw a line at your breaks. So our break is at -5 and 2. So 1, 2, 3, 4, 5. So I have a vertical line right there, and 1, 2 right there. It's a break in the domain. It's literally where our domain breaks. So we got our quadratic, which is going to be on this side. We've got our constant function, which is going to be in between. And then we have our absolute value, which is going to be on that side. So that's our first step. Second step, plug in the points, right? So we'll start with the quadratic. So it says -5. Plug in -5. So -5 plus 6 is 1. 1 squared is 1. And that does not say equal to, so that is an open circle right there. Then your blue one is the constant function. So at -5, 1, 2, 3, 4, 5, 6, 7. That's a closed circle. On this side, it is also a closed circle. Okay. Then our absolute value function, plug in 2, 4 minus 2, which is 2. So 1, 2, open circle. Again, start with the easiest part. So we're going to start with that constant function, which is just a horizontal line. So it just connects these 2 dots right there. Then the quadratic is probably our next easiest one. So this is just the parent function for the quadratic that's been shifted to the left 6 units. So we go left 6 units. So it means that our vertex is 1, 2, 3, 4, 5, 6 right there. So if that's where the vertex is for my quadratic, that means that from the parent function, this is that positive one point where this open circle is, which means the other side has that other point. And then I can go 1, 2, 1, 2, 3, 4 to find that point. And basically, this is my quadratic right there. And make sure that you draw an arrow at the end, okay? So that I know that it keeps going, okay? Because if not, if you just stopped it here, that's making it look like it's stopping right there, okay? I know that it seems elementary, but please do that. Now, the absolute value's got a little bit more going on because we actually have a horizontal reflection. Okay, so I rewrite it like that, so it kind of gives me an idea what's going on. Also, there's another way of doing it. If I take that negative out, I can see that my true shift is to the right 4. So basically, 1, 2, 3, 4, that's where the vertex is, right there. It's been reflected. This is actually a reflection over the y-axis, but when you deal with the absolute value function, it look exactly the same. It's just going to change the direction of my shift, okay? There's been no vertical stretch, so basically I can use a slope. So those are my points. So it's slope of 1. And that's what you should see.